Okay, now let's continue with this one as I've promised. Okay, let's discuss a few things here. We've got two exponents and two trig functions. So we don't really care about the trig functions that much. We only care about the exponents. So if we give an exponent and we can see that this one is odd and this one is even. So when we give an odd and even, we go to the odd and we split the odd. When we given two odds, let's say this was cos raised to 5, we were gonna split the smaller odd. We're not gonna split this one. We're gonna come to this one and split it because it's the smaller odd. So the procedure of going about is almost the same. So now let's rewrite that and split the odd. So this is gonna be sine squared now, x over 2 sine x over 2 cos raised to 4 x over 2 dx. So now we've got this one which we can change. Remember, we want to use that, you remember that trig identity which says sine squared x, on this case let's just say x over 2 plus cos squared x over 2 is equal to 1, which makes sine squared x over 2 be equal to 1 minus cos squared x over 2. Let's go back to our original color. So now we replace that with 1 minus cos squared x over 2 and we still write sine x over 2 cos raised to 4 x over 2 dx. Now we want to make u equal to cos x over 2. Let's do that. U equal to cos x over 2. And we want to get du over dx. We are differentiating. So cos would be minus sine x over 2. Now when we're differentiating, we must multiply with the derivative, which is 1 over 2. Then we make du the subject of the formula. Du is gonna be 1 over 2 sine that's x over 2 dx. Now check to our original equation. We do have, let's change the color. We have this, which is what we have here. We have dx, which is what we have there. but we don't have 1 over 2. That means to get rid of this 1 over 2, we must multiply by 2 over 1, 2 over 1, minus, minus, so the sign goes away, that 2 goes away. So now we would substitute sine x over 2 dx with minus 2 du, and we would substitute cos x over 2 with u. Let's do that. So we have 1 minus u squared, and that one is substituted also with u raised to 4, and the sine x over 2 dx is substituted by minus 2 du. So now we want to take minus 2 and put at the back of the integral sign, then we would be left with 1 minus u squared and u raised to 4 du. So now we want to get rid of this, so we would have minus 2, and then we would have u raised to 4, and we would have u raised to 6, because the exponents will add when we multiply. Du. Now we can integrate this. Minus 2, open the brackets, so this becomes u raised to 5 over 5, and this becomes u raised to 7 over 7 plus c. Now we can bring back what was u, and what was u really? Minus 2, u was cos x over 2. So we'll say cos squared x over 2 all divided by 5 minus cos squared x over 2 divided by 7 plus c. Now we need to take these two inside now. This is gonna give us minus 2 cos x over 2 divided by 5. This cos is raised to what now? Why did I raise that to 2? Should have raised that to 5 and raised this to 7. So that is 5, and that is gonna be plus 2 over 7 cos raised to 7 x over 2 plus c. So that would be our final answer for this one.